So we're working out the form of the unitary operator that describes translation. Now what do we expect this operator to do? We expect it to take some wave function, so let's just draw some wave function in one dimension, and initially it might be, I don't know, bumped around 0, something like that. So this would be wave function psi of x, and our position here would be x. And then after the transformation, we want it to be that same thing translated over, so that would be x naught, say, which looks exactly like a translation by x naught. So if we look at the state in the position representation, so there's our state, and forgiveness for using psi again, but we've got these coefficients psi of x, and the basis vectors are the position eigenstates, x. So what we want is we want this to have moved over, and so we want the translation t of x naught acting on this thing. Our target is going to be that same wave function moved over like that. Put another way, that would take the eigenstate x and take it to x plus x naught. Okay, so how are we going to construct that? What kind of operator does this? Well, as you can see, supposing we expand this out, this is an operator, so it can go through the sum. Integrals are sums, remember? It can go through complex numbers, they don't do anything. So this is the same as this. So this translation operator acting on that has to work that way. So now we know that this operator here, remember this was supposed to try and turn this thing into x plus x naught. And so at some level, we could write as our guess, it's supposed to take us from x and get us to x plus x naught. Now what's wrong with that? What's wrong with that is, of course, that x here is a dummy variable. It doesn't mean anything. Which x do you mean? Well, what I really mean is I mean all the x's. So let's try something like that. Alright, so let's try applying it. So t of x naught acting on x is going to be equal to this. Now, when I expand this out, remember this x is a dummy variable, so I'm going to have to choose a different variable. So I'll use y this time. Y plus x naught, y, act that on x. What's this thing here? This thing here is a delta function. Because it's a continuous index, it's going to be a Dirac delta function. And that means I can actually perform the y integral, and I'll end up with x plus x naught. So that looks good. So that's actually what we're after. So in other words, our guess was right. And what we've got in this box here is the right answer. And it's easy enough to apply it to here to make sure we've got the right answer, so we'll do that. So if we take t of x naught and act it on our state, get all of this as we just required. We get x plus x naught, and then a change of dummy variable, shifting everything back by x naught. And that's what we're after in the first place.